Hi everybody, in this video, let's look at some SPM partial questions. So in this video, I will focus on Form 4, Chapter 2, Quadratic Function. Now let's look at the first question. It's given that f of x is equal to x squared plus 3x minus 4. So for part A, we want to find the range of the value of x such that f of x is greater than 0. It means that this whole thing greater than 0. So x squared plus 3x minus 4 greater than 0. So here I'm going to do some factorization. So for this factorization part, if you are not sure to do it mentally, how to do it mentally, you can just use a calculator to help you. Okay, so actually how do we get this one? Still remember you learned in Form 2. Let me do a quick revision for you. Okay, we are going to fill in 6 numbers here. 1, 2, 3, 4, 5, 6. What times what will give you x squared? So you need to separate the x squared. So it will be x times x. So what times what will give you negative 4? Just focus on 4. Forget about the negative. So let's say if you try 2 and 2. When you do cross multiplication, you will get 2x. Here you will get 2x. Then for this part, you need to add up together. So add these two terms together. Is that possible for you to get plus 3x? No, right? It's not possible. So we know that this combination is actually not correct. So I'm going to use 1 and 4. So this is 1x. You just need to write x. This is 4x. Now, is that possible for us to get plus positive 3x? Yes. I write plus over here, this minus. So if this is negative, here will be negative. If it is positive, here will be positive. And make sure that the coefficient for the x part is all positive. So it's easier for you to determine the sign here. Okay, now let's double check. X times x, you get x squared, right? Okay, these two multiplied together, you get negative 4. Correct. These two add up together. This is multiply. This is multiply. For the last part is plus. Okay, these two add up together, you get plus 3x, which is correct. So our factorization is correct. X minus 1, x plus 4. Okay, I want this to be greater than 0. So what I'm going to do next is to sketch a graph for this function. So I know that the shape of the graph is a quadratic graph, it's a parabola, right? And smiling face. Now I'm going to find the two value here. So this is actually x-axis, right? On x-axis, we know that y is equal to 0. So let this whole thing equal to 0. And x minus 1 equal to 0, or x plus 4 equal to 0. From here, we know x is equal to 1 and x is equal to negative 4. Now we know this is negative 4, this is 1. So we want this to be greater than 0 here, right? Here. So from the graph that we sketch, we know that the range of x will be less than negative 4 or greater than 1. So x is negative, x is less than negative 4 or x is greater than 1. Okay, this is our answer for part A. Let's say if you want to use your calculator to help you check the answer, you can actually do it this way. Search for inequality. The degree will be 2. And then choose the one that you want to solve. So this is a greater than, right? Greater than will be the first one. Just key in all the coefficients here. This is 1. Key in 1. And then you already have a plus sign over here. So for plus 3x, you just need to key in 3. But for negative, you have to key in negative. Okay, then we got, see, the range of x. X is less than negative 4 or x is greater than 1. So this is the way how do we use our calculator to help us check the answer. Now let's go to the part B. The equation px plus q minus f of x is equal to 0 such that p and q are constant has roots alpha and beta. Okay, px plus q minus f of x is equal to 0. Okay, so px plus q minus f of x, which is this one. But for this part, you need to be more careful. If I write this way, which is not correct, because minus this whole thing, right? I have to put a parenthesis over here. Okay, next step, I'm going to open up the parenthesis by bringing in the negative sign. Negative, positive, you get negative, negative, positive, you get negative, negative, negative become positive. So now I'm going to rearrange all the terms here. Okay, so here let me do some factorization. Okay, now from this quadratic equation, we know that the a is equal to -1, right? The b will be equal to p minus 3, and the c is equal to 4 plus q. Now, we want to state the value of alpha plus beta and alpha times beta in terms of p and or q. Okay, alpha plus beta is actually equal to, this is sum of root, right? Sum of root, what's the formula? Still remember, sum of root, the formula is negative b over a. Remember, we have a negative over here. Product of roots, the formula is c over a, no negative. So sum of roots is negative b over a, negative b over a. Okay, so be careful for this one. If you write that this is not correct. If you write this is not correct. But if you put a parenthesis, yes, it's correct. Now, negative, negative become positive. So we know that alpha plus beta is equal to p minus 3. Okay, this is our answer. Alpha plus beta. Now, let us proceed to alpha times beta. Alpha times beta, which is equal to, this is product of roots, c over a, no negative. So c over a. So it will become -4, -4 minus q. Okay, this is alpha times beta. Now let's go to second part of part B. The root of the quadratic equation for this one are this 2 over alpha and 2 over beta, such that r is a constant. We want to express p in terms of q. Okay, now how do we do that? So this one you have to be more careful. X squared plus rx plus plus r, right, is equal to 10. This is not 0. So what do we need to do? For the first step, we will need to bring the 10 over here. So it will become x squared plus rx plus r minus 10 is equal to 0. So after we arrange it this way, then only we can start to determine what's the value of a, b, and c. So from here, we know that a is equal to 1, b is equal to r, c is equal to r minus 10. Okay, so now, given by the quotient, the root of this quadratic equation is equal to 2 over alpha and 2 over beta. So sum of root 2 over alpha plus 2 over beta will be equal to negative b over a, right? Negative b over a. So 1, you don't have to write 1, is okay. So here, let me combine these two fractions together. Times beta times beta times alpha times alpha. So it will become 2 beta plus 2 alpha. Okay, this will be alpha plus beta is equal to negative r. Okay, so do we have the value of alpha and beta? Let me do factorization for this part first. Beta plus alpha. Okay, alpha, beta. Now, 2. Do we have the value here? Yes, we know this is equal to p minus 3. P minus 3. So how about this one? Negative 4 minus q. Okay, so I try to multiply both sides by negative 1 so that we will be able to get rid of this negative. So it will be negative 2 p minus 3 over negative 4 minus q. And this will become positive r. Okay, I just stop here first. Let be the first equation. Now let's go to second part. Alpha times beta. Sorry, this is not alpha times beta. This is 2 alpha times 2. 2 over alpha times 2 over beta. This is product of root. So 2 over alpha times 2 over beta. This is product of root. So what's the formula? C over A. So C will be this over A. A is equal to 1. So you don't have to write 1, it's okay. So 2 times 2, you get 4. Alpha times beta is equal to this. This is R minus 10. Okay, what I'm going to do here, I bring the negative 10, go to another side. Become plus 10. Then it's equal to R. Okay, let me combine these two fractions together. So this is equal to 1, right? If I want to combine these two together, I want to combine these two terms together, and they need to have the same denominator. So what I'm going to do here, 4 over minus negative 4 minus q plus 10 times negative 4 minus q. And this is negative 4 minus q. So in the exam, actually you don't have to show this step, it's okay. But I write it for you so that you understand better what I'm doing. Four plus 10 times negative 4 minus q over negative 4 minus q is equal to r. So let me do some expansion over here. Positive, negative become negative, positive, negative become negative 10q. Okay, let me double check. Yes, correct. Now, 4 minus 40, you will get negative 36, right? Minus 10q over negative 4 minus q is equal to r. So this is a second equation. Now, we want to express p in terms of q. We don't want to see r. So this r is equal to this. At the same time, r is also equal to this. So we can say that 1 is actually equal to 2. The first equation is equal to the second equation. So this whole thing is equal to this. I'm going to write negative 2 times p minus 3 over negative 4 minus q is equal to negative 36 minus 10q over negative 4 minus q. Okay, the both sides have the exactly the same denominator part, so I can just ignore this two. This whole thing is equal to this. So, not enough space. Okay, so let me do some expansion over here. Negative 2p, negative negative become positive. This is minus 10q Okay, we need to express P in terms of Q, right? So we have to isolate the P. So negative 2P is equal to negative 36 minus 10Q minus 6. Okay, quite long for this part. Okay, negative 2P is equal to negative 36 minus 6. You will get negative 42 minus 10Q. Okay, negative 2 times P. It will become this whole thing divided by negative 2. Okay, what I'm going to do next, here I do some factorization. Negative 2. So try to think, negative 2 multiplied by what number will give you 42? 21, right? 21. So be careful whenever you factorize a negative number, all the sign here will change. Negative will become positive, negative will become positive. Okay, let me double check. Negative 2 times 21, you will get negative 42. Yes, correct. Negative 2 times 5Q, you get negative 10Q. Okay, here we have negative 2, last part. We just simplify it. So the final answer will be P equal to 21 plus 5Q. Okay, let me check the answer. P is equal to 21 plus 5Q. Okay, this is a way how we solve this sub question. Now let's look at second questions. This is also SPM 2021, but this is paper 2. Just now one is paper 1. So this is paper 2, section A, question number 4. Diagram 2 shows a curve of quadratic function f of x is equal to x minus 3 square plus k, and g of x, which is equal to this. They intersect the x-axis at two same point, which is here and here. Let me use red color. Find the value of k. Now let us focus on this. F of x is equal to x minus 3 square plus k. We want to find the value of k. So how do we find the value of k? We can use this point. We know that the coordinate of this point is 0, 5, right? So this f of x is the same thing as y. So it's actually the same thing as this one, because f of x may make you a little bit confused. So it's actually the same thing as this one, right? So the 5 will be here, and x here, 0, we can bring in here. At point 0, 5. So this is y, right? 5. And the 0 I'm going to bring in here. Okay, now we only have one variable, which is k. Sorry, this is a constant. So we can find the value of k easily. Negative 3 squared, you will get 9. K is equal to 9 minus 5, which is equal to negative 4. Okay, k is equal to negative 4. So now we know that this equation is equal to x minus 3 squared minus 4. Let's proceed to the second part. Find the value of m. Okay, we want to find the value of m. Try to look at this equation. X minus 3 squared minus 4. Can you get the coordinate for the maximum? Oh, sorry. This is this one. So is that possible for you to get the coordinate of the minimum point just by looking at this function? Yes, we know that this is vertex form, right? So we know that the minimum point here is actually equal to 3 and negative 4. 3 comma negative 4. So for maximum or minimum, this part inside the parentheses is equal to 0. So x minus 3 is equal to 0, x is equal to 3. And this is the minimum value, negative 4. Okay, and then you look at this one. G of x is equal to minus negative 3x squared plus m minus 4 plus, not plus, sorry, times x minus 15. Okay, this is A, this is B, and this is C. Still remember, for maximum point or minimum point, this is minimum, this is maximum, the x part will be always equal to negative b over 2a. Still remember? Negative b over 2a. So this is why we can find y using the value of x. Since that they intersect the same, the x-axis at the same point, so we know that this coordinate, this point, the x part will be always, sorry, not always, will be also equal to 3. But we don't know the y. Okay. Negative b over 2a. So as I told just now, this is actually equal to negative b over 2a. From here, we know that negative b over 2a is actually equal to 3. Now, we can get the m easily. So this is negative 6. Cancel out the negative sign. So m minus 4 is equal to 3. 6, you get 18. So m is equal to 18 plus 4, which is equal to 22. M is equal to 22. Now let's go to the last part, B2. Hence, find the coordinate of the maximum point of, we want to find this. So we already know the coordinate for the x coordinate for the maximum point, but we still need to find the y coordinate. And the question asks us to use the method of completing the square. So we need to follow the requirement of the question. So we need to do completing the square. G of x is equal to negative 3x squared plus m we got just now, which is equal to 22. 22 minus 4, x minus 15. Okay. This is 18. 18x minus 15. Right? Okay, how do we do the complete square? I hope that you still remember. To do the complete square, first step, we need to make sure that the coefficient of x squared is positive 1. So here is negative 3. What I'm going to do here is I'm going to bring out the negative 3. Whenever you factorize a negative number, all the sign inside here all change. So negative will become positive. Positive become negative. Negative become positive. Okay, that's lovely chat. Negative 3x squared, negative become positive. So 3, 6, 18. Negative, positive become negative. 3, 5, 15. Okay, next step. We need to do completing a square. Now, the coefficient of x squared is already positive 1. We can start doing completing square. Let me show you the clearer way first. X squared minus 6x. This one we just copy. And then we add one more thing. So just look at this. If this is negative 6, you just write negative 6. And then always divided by 2. Always divided by 2. Square. This thing is, we added ourselves, right? Means that we already changed the value. So we need to minus back this whole thing. We add this one, we minus back, we keep the value still the same. And don't forget, you need to copy this one. Okay. Now, this part. This is actually, this whole part is actually equal to x minus 3. Negative 6 divided by 2, you will get negative 3. So x minus 3. How do I get negative 3? Negative 6 divided by 2. Okay, you try to expand this one. You actually equal to this. Let me show you here. X minus 3 square. I hope that you still remember the formula that you learned before. X square minus 6x plus 9. Is this equal to this? Yes, right? Negative 6 divided by 3. Negative 6 divided by 2, which is equal to negative 3. Negative 3 you square it, you will get positive 9. And don't forget to write this. So this is negative 3, you square it, you get 9 plus 5. Okay. Then just use the calculator to help you to do the next step. Negative 3 bring in here. Negative 9 plus 5, you get negative 4. Negative 4 times negative 3, you get positive 12. Okay, now we can get the maximum point just by looking at this function, maximum point. Okay. As I told you just now, since this is our vertex form, right? This part inside the parentheses will be equal to 0 when that is a maximum point or minimum point. So x minus 3 equals 0, x is equal to 3. And the last part here is a maximum value or minimum value. Since this is a negative, you have a negative sign, right? This is set phase. So therefore this is a maximum point, so maximum value. Okay, this is the answer for B2. So if this step will make you confused, but I suggest you to use this method, write it, show your step clearer. Let's say if you really cannot do it this way, maybe you can try this way, but I do not encourage you to do like this because it's a little bit shortcut. I worry that you will lose some mark over there. Okay. So this is another way. Copy this one. Once the coefficient of x squared become 1, then you can start to do it this way. Put a parenthesis square minus. Write this one first. And then x, you copy x. Be careful, only x, not x squared. And this is negative, you just write negative. If this is positive, you write positive. And look at the number here. 6 always take a number divided by 2. So normally, if I see an integer, I will think divided by 2. If I see a fraction, I will think times 1 over 2. Times 1 over 2 is actually the same thing as divided by 2, right? So 6 divided by 2, you will get 3. And then no matter this is negative or positive, here always will be negative. So minus what? Take this number, square it. 3 squared, you will get 9. You will still get the same answer. Okay, bring in the 3. And then here, the same thing, right? Negative 9 plus 5, you get negative 4. Negative 4 times negative 3, you get plus 12. It's exactly the same. Okay, so this is a way how we solve this our question. Let's say if you want to use your calculator to help you to check the answer, you can do it this way. Go to equation and polynomial. Degree is 2. Now, let me key in all the coefficient here, negative 3. And here already have a plus sign. You don't need to key in the plus, is okay. I just key in 18. But for negative, you have to key in because this is plus. You can key in this negative. You can use this negative button. This or this, both will be okay. Okay, then press equal, equal again, and equal again. Now you see the maximum of y, the maximum point for this function will happen at x equal to 3. And what's the y coordinate? Y equal to 12. This means that our answer correct. This is a way how do we use our calculator to check the answer. Okay, now let's look at another question. This is SPM 2022, paper 1, section B, question number 14. Diagram 10 shows a curve of a quadratic function f of x. Let me label over here. F of x is equal to 2x squared plus hx minus 2k plus 5. Okay, such that h and k are constant and the curve has a minimum point at t. This is a minimum point. Let me use red color. Minimum point. Determine the range of value of x of f of x is greater than 0. This is f of x. If we want the f of x is greater than 0, which means this part, right? And this part. So the value of x, the range of x is here or here, right? So we already got half of our answer. So which is f of x, no sorry, not f of x is less than -2. This is one part of our answer. X is less than -2. But how about this one? We don't know the value here. So we need to get the value here. What is the value of x here? I mean the x-intercept. So try to think. You know that this is a quadratic function, right? So, and this is a minimum point. This will be the axis of the metric. So the distance here and the distance here will be the same. If you take these two numbers, add up together, divided by 2, you get this, right? So I don't know this, I just let it be p. So from here I know that p plus -2 divided by 2 will give us this, which is -1/4. So p plus minus, you will get negative. 2 bring it over here. Okay, so this is -1/2. So p is equal to -1/2 plus 2. So this one you can just press your calculator. 3/2. So now I know this is 3/2. This is 3/2. Now we got the answer, which is x is greater than 3/2. Okay, let me check the answer. X is greater than 3/2. Okay, this is the answer for part A. Now let's go to part B. The questions ask us to prove that k is greater than this whole thing. F of x is equal to this. On x-axis, y is equal to 0. Since this is f of x, I will write f of x is equal to 0. So 2x squared plus hx minus 2k plus 5 is equal to 0. Now, you know, this is a is equal to 2, b is equal to h, and c is equal to -2k plus 5, or you can write 5 minus 2k. It's the same thing. So why do I need to determine the value of a, b, and c? Still remember, you learned about the types of root before, the types of root for an equation. Let me write over here, b squared minus 4ac. If this is greater than 0, there will be two different real roots or two distinct real roots. If b squared minus 4ac is equal to 0, two equal roots. If b squared minus 4ac is equal to, is less than 0, no real root. Okay, let me repeat again. This is two different real root. This is two equal real root, and this is no real root. So when you look at this graph, you know that there are two different real root, right? How do we know two different real root? Two different points. The root will be -2 and 3/2, which means two different real root or two distinct real root. And from here, we know that the b squared minus 4ac must be greater than 0, right? Okay, so I'm going to write this. This is discriminant b squared minus 4ac. So b squared minus 4ac will be greater than 0. So we try to rearrange all these terms so that we'll be able to get this. So if now you have three parts over here, if you worry that you will make mistake, I will suggest you to do this two part first, and then this one you just copy, so that not that easy for you to make mistake. And then we do some expansion over here. Okay, this will be 40 and this will be negative, positive, partial. Now we want the k on the left hand side. So what I'm going to do is bring this 2 go to another side. So this negative 40 become positive 40, positive h squared become minus h squared. Okay, almost there. Divide by 16. Oh, is that correct? Let me check. 40 minus h squared. Okay, correct. Proven. This is a way how we solve this our question. Now let's go to the last part. Again, we need to use completing a square to help us to find the minimum value. Okay, so this is minimum value. It means that we only want the last part. We don't have to give the coordinate of the minimum point. We just need the minimum value. Okay, so let me continue doing here. We know that f of x is equal to 2x squared plus hx minus 2k plus 5. We want to find the minimum value. So some question they will guide you. For example, they will ask you to find the value of h first, then ask you to get the minimum value. This question does not ask you to find the value of h, but actually later on you need to find the value of h. Okay, let's say I don't know that I need to find the value of h. I just start straight away do the completed square. So I will do it this way. Remember, whenever you want to do the completed square, make sure the coefficient of x squared is positive 1. So now I'm going to bring the 2 go out, and everything here divided by 2. H over 2 x minus k plus 5 over 2. Let me double check. Is this correct? Okay, correct. Now I can start to do the completing square. So I'm going to use the second way, which one, but I do not suggest you to do it this way. I suggest you to write a clearer step. Okay, now x plus, this is 1 over 2. As I told just now, whenever I see a fraction, I would think about times 1 over 2. Right? This is 1 over 2 times 1 over 2. Compare with 1 over 2 divided by 2. It is harder for you to think, right? 1 over 2 times 1 over 2, you get 1 over 4. So here I'm going to write 1 over 4. Minus what? This whole thing square. You get 1, this is 16. And then don't forget to copy this whole thing, k. Oh, sorry, I forgot to write the h. This is h over 2. Let me double check. Okay, yes. This is h over 2. So h over 2 times 1 over 2, you will get h over 4. This is h over 4. Is that correct? Let me see. Yes, correct. Okay, minus h squared over this square, you get 16. And then don't forget to copy this whole thing. Okay, so next step. Bring in the 2. Okay, I make a mistake here. Let me double check. The 2 times this one, you get this. The 2 times this one. Okay, this is not correct. Should be negative 2k. Negative 2k, and this time this one you get plus 5. Is that correct? Yes, correct. Now, from here, we know this is surrounding phase, right? So the minimum value will be this. But the problem is we don't have h. We want to get the h. So we know the minimum value is equal to negative h squared over 8 minus 2k plus 5. Okay, we want to find the h. Try to think, how do we get the value of h? As I told just now, for the minimum point or maximum point, the x coordinate will be always equal to negative b over 2a, right? So given by the questions x is equal to negative 1 over 4, from here we know that negative b over 2a will actually equal to negative 1 over 4, right? So negative b over 2a is equal to negative 1 over 4. So this is negative h over 4 So from here, we know that h is actually equal to 1. This whole thing, let me use another color. This whole thing, I bring it to another side. It becomes h is equal to negative 1/4 times negative 4. Cancel up. So h is equal to negative, negative become positive. h is equal to 1. So you just bring in the 1 over here and press your calculator. Oh, sorry. The k, let me see the k. We don't need the k because the question asks us to find the minimum value of the function f of x in terms of k. So the k is okay. Just give our answer in terms of k. Negative h is equal to 1. 1 square. Okay, let me write 1 square. 2k plus 5. So 1 square is still 1. So negative. Let me use my calculator. Okay, let me check the answer. Is it correct? Minimum value is equal to... Okay, correct. This is a way how we solve this type of question. Let's try one more question. This is the last question for this video. Now, this is also SPM question, SPM 2022, paper 2, section A, question number 3. A quadratic function is given by, okay, let me write down the quadratic function. F of x is equal to 2x squared minus 5x plus p. Okay, such that p is a constant. We want to... Okay, the root of the quadratic equation when f of x is equal to 0, it means that 2x squared minus 5x plus p is equal to 0. The root will be, the root of the quadratic equation is alpha and beta. We want to form a quadratic equation which has a root of 2 alpha minus 1 and 2 beta minus 1. This is a formula that we need to... How do we form a quadratic equation? X squared minus sum of root x plus product of root is equal to 0, right? So this means that we need to find sum of root and product of root. Okay, what is the value of sum of root? Alpha plus beta is equal to negative b over a. Negative b over a. So negative become positive. 5 over 2. So what's the value of alpha times beta? Product of root c over a. No negative, be careful. C over a. Okay, we just stop here. Now, this is a new root. We want to find the sum of root, which is equal to 2 alpha minus 1 plus 2 beta minus 1. So 2 alpha plus 2 beta minus 2. So here I'm going to do some factorization. You will get alpha plus beta over here. 2 times alpha plus beta minus 2. Do we have this? Yes, which is 5 over 2. So you get 5 minus 2, which is equal to 3. Now we know the sum of root is equal to 3. Let me proceed to find product of root. Product of root is this one times this one. So 2 alpha minus 1 times 2 beta minus 1. Okay, do some expansion over here. 2 you get 4 alpha beta. Negative 2 alpha. Negative 2 beta. Negative become positive. Okay. Alpha beta is equal to this. Okay, I'm going to do some factorization here, so be careful. Positive. So as I told just now, when you bring a negative number out, the sign all will change. Negative become positive. Negative become positive. Okay, let me double check. Yes, correct. Simplify. You get 2p minus 2 alpha plus beta, which is 5 over 2 plus 1. Simplify this 2, you will get negative, 2p minus 5 plus 1. So it will be 2p minus 4. Okay, 2p minus 4. Now we have the value of sum of root and product of root. We just use this formula to help us to form the equation. So the equation will be x squared minus sum of root x plus product of root 2p minus 4 is equal to 0. Okay, let me check the answer. 2x squared, sorry. X squared minus 3x plus 2p minus 4 equals 0. Okay, correct. This is the answer for part A. Now let's go to the last part, part B. Given that the straight line y equal to x plus 1 touches the curve y equal to f of x, and we want to find the value of p. Okay, f of x is equal to 2x squared minus 5x plus p. So another straight line which is equal to, this is not a straight line, this is a curve, and this is a straight line. Let's say if you want to find the intersection point between these two, right? This is the same thing as y is equal to 2x squared minus 5x plus p. So we will solve them simultaneously, right? So since this is y, this is equal to y, we can say this is equal to this, right? So 2x squared minus 5x plus p is equal to x plus 1. So if we solve this equation, we find the value of x, that will be the intersection point between the curve and the straight line. But it's okay, we don't have to find the intersection point because the question does not answer the intersection point, the coordinate of the intersection point. The question is asking about the value of p. So since that the question tells you touches the curve, okay, sorry, let me see again. I think the question want to mention touches the curve y equal to f of x at only one point, which means that this is actually the tangent of this. Okay, let me assume that the question want to tell you that this straight line only touches the f of x at one point. Okay, let me continue doing this. 2x squared minus 5x plus p minus x minus 1 is equal to 0. So 2x squared minus 6x plus p minus 1 is equal to 0. So a is equal to 2, b is equal to negative 6, and c is equal to p minus 1. So when this is equal to tangent of this touches at the curve one point, this means that you will only be able to get one value of x. That means two equal root. Okay, two equal root. So we know that b squared minus 4ac will be equal to 0. Okay, b squared minus 4ac is equal to 0. b squared minus 4ac is equal to 0. Okay, let me continue doing this. Hopefully we can get the answer. So this is 36, and as I told just now, I will encourage you to do this two part first. Okay, then do some expansion over here. (36) plus 8, you will get 44. 44 minus 8p is equal to 0. So from here, we know that negative 8p is equal to negative 44. So p is equal to negative 44 divided by negative 8. P is equal to, the negative can just cancel out, and divided by 2, divided by 2. Oh, we can divide it by 4. So you will get 11, and this will get 2. Okay, correct. This is the answer for part B. That's all for this video. See you in the next video. Bye bye.